We're going to look at the efficiency of different machines, and we're going to look at Sankey diagrams. Now the efficiency is a ratio of two energies or two powers. Most of the time it will be a ratio of energies, and it's basically how does the useful energy you get out compare with the amount of energy you have to put in. And we just write this as a ratio as the useful energy out divided by the energy in, or rather the useful work output divided by the work input. And we're going to end up with a fraction which we just have to multiply by 100 to get it as a percentage. Here's an example. This filament lamp is supplied with 100 joules of electrical energy, and then it converts 45 joules of those into light energy. What is the efficiency of the light bulb? So we get 45 and we have to put in 100 joules of electrical energy. What is that as a percentage? So the efficiency is the useful energy out divided by the work that's put in. So it's 45 compared to 100, which is 0.45. But we want that as a percentage, so we just multiply by 100 and we get 45%. What is the work done to raise a block up a ramp? So we're going to drag this block, 800 Newton block, up a ramp. Now first we're going to drag it up the slope. The work done is the force times distance. The force to drag it up the slope is 250 newtons. The distance is 8 meters. So work done is force times distance, which is 250 times by 8, gives a value of 2000 joules to drag the block up the slope. That's the work we need to put in to make it go up the slope. However, what is actually the gain in the height? That's basically done by looking at how much height it gains against gravity. And to do this, we basically find out what is the work done to lift it up by 2 meters. So the work done is force times distance. The force is 800 newtons because that's the force that works against gravity. And the height lifted against gravity is 2 meters. So it's going to be 800 times by 2, which gives us 1600 joules. Now, we're able to get effectively 1600 joules of energy out of this block, but we have to put 2000 joules to drag it up the slope. So some energy gets lost somewhere, 400 joules gets lost. So we need to look at that. So what is the efficiency? The work out divided by the work in. The work out is what effectively we gain, which is the 1600 divided by the 2000, which we have to put in to drag it up the slope in the first place. So 0.8 times 100% is 80%. So where's the other 20% gone? Well, we had to drag it up the slope, and the slope isn't smooth and it's not on wheels, so some was lost in friction. And that friction gets turned into heat. And where does that heat go? It gets lost to the surroundings. To give an example how friction turns into heat, what you can do is now rub your hands together and rub them really, really hard and push them really hard into each other and rub as fast as you can, and they should start getting hot. So when you get friction, you get heat, and that heat gets lost into the surroundings. Now, if you're rubbing your hands and they're not getting hot, you're not rubbing them hard enough. So you have to rub it faster and faster. If you do it really well, your hands should almost be burning. That's what I want you to do. So, what we need to look at now is the Sankey diagram. The Sankey diagram is basically a graphical way of showing the energy that goes in compared to the energy, the useful energy that comes out, and the energy that's wasted. And the way it works is that it goes from left to right. The energy input is on the left-hand side of the diagram and is the width of the arrow. The wasted energy goes up or goes down, and in this case that must be the width there. The useful energy comes out on the right-hand side, and the width of the arrow will give you the idea of how much energy is actually useful. So let's look here. This width is 20 units. And if you count the units on the right hand side, that's around 6 units. Now, how efficient is this? Well, basically we're comparing 20 units that you have to put in, but you only get 6 units out. So the efficiency is the energy out divided by the energy in, which is 6 divided by 20, gives a value of 30%. Where does the energy go? Well, we don't know. We don't know what the mechanism is, but it probably gets lost as heat somewhere. What is the efficiency of this compact fluorescent lamp? We have the efficiency is energy out divided by energy in. The energy out is 0.8 joules. The energy in is it 8.2 or is it 9 joules? Well, the energy in is 9 joules. The energy lost is 8.2. So it's out, which is 0.8, divided by in, which is 9. So we get this value times by 100%, gives us 8.9% efficiency. So where does this lost energy go? As I said before, most of this energy gets lost as heat to the surroundings. And there you have it. Easy peasy, lemon squeezy.